Welcome back, my chemistry friends. This is Professor Corey, and what I have for you today is I'm just going to kind of walk through a question where we use the Clausius-Clapeyron equation. And the question comes right from your summary packet, Chapter 11, your first summary packet. I put the problem in here so you can see the problem, and I'm just going to walk through one way to calculate it. And there's several ways to do this. So the first thing I'm going to do before I even start writing this out is I'm going to just kind of read the question and try to figure out what's going on. And ultimately what we're trying to do is calculate a vapor pressure, and the temperature has been lowered. So we have a vapor pressure and a temperature, and the temperature's lowered. And if I think about this, I'm like, okay, temperature goes down, well, my vapor pressure should go down. And that's going to be really important, because if I do all this big calculation and I get a number that's higher than 400 millimeters mercury, then I probably made a mistake. So real easy to make mistakes in this type of problem, and I'm going to try to point out a few places where you can go wrong. And right away, I'm going to show you, notice how our constant here had units of joules per mole Kelvin. Well, my enthalpy of vaporization was in kilojoules per mole. So I did convert that, and I didn't show you how I did that. So hopefully you can do that one on your own. So I just went from kilojoules to joules, and I've got this number in here instead. And this negative out here, I didn't put the equation, I should have put the equation in, but the negative that's something that I forget often. So if I had a highlighter when I'm doing these problems, I'll highlight this, just to draw attention to it. So watch out for that. So what I've done is I've set up the equation, and I'm going to solve for P2. I'm going to call that P2. So my first pressure, 400 millimeters mercury, that's here. That corresponds to, if that's going to be P1, it's got to correspond to T1. That's over here at 2590. So I've set up the problem. The first thing I'm going to do is I'm going to rearrange this log P2 over 400, and I can simply rewrite that as the log of P2 minus the log of 400 millimeters mercury. The rest stays the same. All of this is the same. I didn't do anything to this yet. All I've done is just rearrange this this equation. You don't have to do it this way, but this works well for me. What I'm trying to do is get the tricky math out of the problem. So next step, I'm going to take the natural log, ln, of 400. So I'm going to do that in a calculator. And in my calculator, I'll put the number in first and then hit the ln. So be careful, not the log log. This is the natural log. So your calculator might be different. You might have to hit the ln first. But this will be a good test for you. All I did is took the natural log of 400, and I've got this number here. And notice I wrote down every single digit, and that's important also with these types of problems. You don't want to round. Rounding can get you into trouble. So all I've done here is taken the natural log of 400. I've got this number. This stays the same. Everything over here stays the same. So I need to switch to another slide, and what I've done is I've put this at the top. This is not going to change. And there we go. So this is where we were on the previous slide. And the next thing I'm going to do is I'm going to divide. I'm going to take this piece right here. I'm just going to take the negative 296 times 10 to the third, divide by 8.3145. Just one step here. So I do the division. Don't forget that negative. Real easy to do. Notice how these joules and moles cancel out, and I'm left with units of Kelvin here. Again, every single number I got off my calculator, just a simple division. Everything else stayed the same. All right, next step for me, I'm going to go 1 divided by 2560, and that's this number here. And then the minus is just this minus. And then I'm going to go 1 divided by 2590. Again, really, really important that you do not round here. You can see how it'd be really easy to round this to 3.9, and this one's 3.9, and that would be bad. That wouldn't change anything. So all these numbers, you might even want to turn your notebook landscape when you're working these equations, because they can get pretty lengthy. So all I've done there is just done the division, and nothing else changed. This is the same, and all this over here is the same. So next step, I'm actually going to do this subtraction. Within the parentheses, I'm going to take this number, subtract this number, and that's where I got the 4.525 times 10 to the negative 6. I just went to scientific notation there. I was getting lots of zeros, but you could write this out as 0.00, a whole bunch of zeros. That would be fine too. I just chose to go into scientific notation, and again, I have to switch to the next slide. So I'm right here, and that's the same thing right here. I've got my log of P2 minus this number. I've got the negative, don't forget that. That was my subtraction, didn't do any rounding. So the next step, what I'm going to do is I'm going to take this number, the 35,600, and multiply it by this. It's in parentheses. I'm just going to multiply those two. So notice I've got units here, 1 over Kelvin, or Kelvin to the negative 1. They're going to cancel each other. I'm going to be unitless. Don't forget the negative. I've got a negative number, and that's this number here. Again, do not round. Don't do any rounding until we get to the very end. So right here, this is getting more and more manageable, right? So I'm going to move the 5.99 over. I'm going to add 5.99, 1464, 547 to this side. If I do it to one side, I have to do it to the other. And I get the log of P2 equals 5.83, whole bunch of digits. Okay, this is the tricky step. I have to get P2 by itself. And the way we do that is we use this function called an inverse log. And on your calculator, it's going to say e to the x, and it's usually right above the natural log. So you'll have to hit like second function, natural log, and that'll give you the e to the x up here. Your calculator may be different. You'll have to kind of play around with this to figure it out, but this will be a good chance to practice that. So what I've done here is I've got this number in my calculator, and on mine, I just have to hit second function, natural log, which is e to the x, and that's the inverse log, and that gives me P2 at 340. And at this point, I went back to my problem. I had 3 sig figs up here, 3 sig figs here. So I did round this to 3 sig figs because this is my final answer. Now, as a check, I'll say, reflecting back, oh yeah, the temperature went down. I expected my vapor pressure to go down, and it did go down. We're down at 340. I can feel reasonably safe that I did this one correctly. So I hope this is helpful. Give me a thumbs up if you'd like to see more sample problems like this on the Professor's DuBois. Thanks and good night.